So now that we've talked about a relationship, there's nothing special about it. It's just if I give you an X, there should be a Y. They are connected to each other. They have a relationship. Any questions on that? So far, so good? Well, in a function, it's very unique. It's probably not the best example I can give, but it works, especially at our age group. Typically, again, depending on where you live, I suppose, but majority around the world, if you have a person here, they ought to have one significant other. Would you agree? Like as in like, like a relationship, like a special relationship? No? Am I old fashioned? So everyone could have like multiple like, boyfriend, girlfriend, significant other, side chicks, and all that, side boys, whatever you call it. That's okay now? Is that a thing? So if I let's say as a person here, as a man, is it frowned upon, or is it okay for you to have like, for me to have like 10 different girlfriends? Like girlfriends. Hmm? Is it? Oh, I am dated. Oh. Well, I still thought that, I mean, there would be some level of like, I would like that person's attention and only me kind of thing. Am I wrong? Am I? The question was, in this day and age, is it okay? Again, I have to rephrase the question now. Is it okay for me to have like multiple girlfriends, like my main girl and like my 5 different side chicks? Like, is that okay? No, right? Okay, so I'm not like crazy then. It is apparently, right? And I get furious over that. Like, I have seen through my internets, right? Lots of people talking about their, multiple girls, and they're just like, they're trying to fight it out, and they're trying to win his affection. I'm just like, have some self-respect and drop him, right? What is wrong with you saying, no, I'm going to be the best? Who cares? Okay, he's not worth your time, and if he is divvying himself up with 5 other girls, that's just me. And this is all being recorded, so maybe I should edit this. But you get what I'm saying. I don't think that's right. And if you are, sorry for being binary here, but if you are a guy that is working to build a harem, okay, of multiple girls, and shame on you, okay? Don't do it. And again, sorry for being binary, but for those girls who have those significant others who are trying to fight other girls for the attention of, drop that guy. He's not worth your time. Trust. Okay. I want to say I've been there and done that, but I haven't. Just don't do it. I haven't been there. Okay. But the idea is this. Why am I giving you that stupid analogy? It is because what's the difference between a relationship and a function? A function is conservative. A function, for every X, there must only be one Y. If it has more, you do not care about it. Like this. Do you see this X value? The X value of a 0. How many Y's does it have? Shame on that X. Okay? That is not a function. It's just a relation. Get it? Just a relationship. A bad relationship. A function. Every X must only have one Y. With me? With me? I told you it was a terrible example. Anyways, let's be drawing. Got any question? Well, think about it this way. What is the X value of this area right here? No matter what my dot is, my X would be a 0, right? So when I say, okay, X is 0, that means I'm not moving left or right. It's right here. Well, how high am I moving? 0 or -2. There's two possibilities. That's not a function. Get what I'm saying? So take a look here. Here, there are all these arrows, and this 0 had a 0 or a -2. There are two possibilities. In this question, you will see that there's only one possibility for each. So we have -2, -3, 0, 2, and 5. And I'm going to try to do my best. We've got 0, 0, 2, 2, 4, -2, 6, -3, and 8, 5. One line at a time. There are no double two lines coming out of the same X. Yeah? If I were to draw it graphically, you will notice that there are no dots on top of each other. So we have 0, -2. I'll zoom in. 0, -2. We've got 2, -3. We've got 4, 0. What am I doing? I'm just looking left and right. Everyone, you will see that I make lots of these mistakes. Please correct me. 0, 0 is one of them. 2, 2 is one of them. 4, -2. 6, -3. And 8, 5. Oof, that's going to be a rough one. There. Something like that. Mental note, next time, make the graph bigger for my students. Or change the points. So that's it. If I were to take my highlighter and I draw vertical lines, you will see that every single vertical line only has a single dot in it. Whereas if I move it up here, do you see how this vertical line had 2 dots in it? That's literally all you have to do to check if something is a function or not. That, as silly as that sounds, is a test you can do. It's called the vertical line test because mathematicians are so creative, right? It's called a vertical line test. So look at the graphs I'm about to give you here. Okay, the space on top, it says graphically, a function versus a relation is very easy to identify using the vertical AL line test, or VLT just for short. So if you don't have a highlighter, that's okay. Just grab a ruler or a marker or anything straight. So I will use this ruler right here. Okay, and just slide it over. If your ruler cuts through your line only once or touches the line only once at any given point, then it's a function. So once again, is A a function? Yeah, absolutely. It's a function. There is no 2 y's for 1x. So that's a function. You don't have to write over it. You can just write a little f next to it. How about B? I know it's not a connected line, but this dot right here, that dot, that dot, that dot, that dot, that dot, does it touch the ruler more than once? No, that's a function too. People recognize this. What shape is this from last year? Do you know what the special name was? Hands up. We got 2 people, 3 people. Sam? Yeah, absolutely. Okay. The parabola too. You've worked with it before. Let's use a vertical line test. What do you think? Function or no function? Sam? No function? You're not sure? Or look, no, just yes or no. Does this ruler touch the curve more than once at any given point? No, so it's a function. This one is, That's what I mean. You've been working with functions all this time, but we never really called it a function. We just called it a relationship between X and Y. Here are some examples that are not functions. You see it? It touches it in more than one location, touches more than one location. This is a simple relation. Same with this. It's a single vertical line and it has multiple dots on it. That's a relation. Circle, I think you can guess. It touches it more than one location. That's a relation. Yes, Freddie. Yeah. It's that idea that the X affects the Y. It's the independent affects the dependent, right? Amount of hours worked, the money made. It's always sort of one direction like that. Okay. And you will see that on the bottom. So that's pretty much it when it comes to the vertical line test, seeing if something is a function or a relation, and you know what the definition is. Any questions on that? Self-explanatory. So far it's okay, right? Yes. Yes. Right, Nick. So if you are given a question like this on a quiz, I hope that everyone gets 100%. This part, this next little piece, we're probably going to spill over into tomorrow. So I'm going to quickly talk about it. It's this thing called domain versus range. Now, this is where you can write the answers to the questions on the back. I need to talk about it first. We've just learned about functions versus relations. Turn the page. There's one more thing that we need to know in describing graphs correctly. And that is to identify what are the possible X values. I should have 20, right now. 5, 9, 13, 16, 19, 23, 23. No, I counted her. 5, 9, 13, 13, 16, 19. Let's talk. Remember in the previous sheet, we had 2 bubbles. We put all the X's here, and we put all the Y's there. Everyone remember that? In the front of the sheet? If you know that, you've already done domain and range. Domain means what are the possible X values? Tell me all the possible X values. Range means what are all the possible Y values? That's it. Let's keep it simple. Domain of a function, I'll zoom in, is a set of all the possible X values, and the range is all the possible Y values. The concept is so simple, you might actually forget the word domain and range, so please. I'm going to ask you to review when you get home. It's going to be small amounts of homework, but you got to do a little bit every day. All right? I'll distribute that in a second. Let's practice. Let's pretend I give you this as a function or this as a relation. What's the domain? Someone take a brave shot at this. It's the first time you're doing it. Charlie? Yes, please. Good. Right? Literally, the domain is the X values of every single point I gave you. Which means, okay, the range is, and so in numerical order, please, state it.
0 to 4, 6.
Yeah. You're like, Mr. Kim, that's pretty simple. Yeah, but it can get a little bit more complicated. And here's how. What about this graph? What are all the possible X values? Ooh. Now's the time to get a little creative. What are the possible x values? Be wrong, people. Be wrong. I encourage you. I'll be so happy if you were wrong today.
Couldn't that be infinite when there's arrows at the end of the line?
Correct. In fact, you are absolutely right. It goes forever this way and forever this way. But there's a catch. Not every single number. What do you notice about between those dots? Well, let's put it this way. Is it a straight line, a solid line, or is it all filled though? Or are there gaps? If there are gaps, it means not all the numbers are included. What numbers are allowed? What number is right here?
0,
And
1, 2, 3, 4.
so it goes 1, 2, 3, 4, all the way to infinity. -1, -2, -3, all the way to negative infinity. Nothing in between those whole numbers. No decimals. So how do I communicate to the world that any number is okay as long as it's not a decimal? You have to get into the family of numbers. There is a family of numbers out there. We gave it a name where any number is okay as long as it's not a decimal. And that is called, starts with an I. Integers. So you could write it in two different ways. I'm going to give you two options. You can say negative infinity, dot, 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 -1, 0, 1, dot, 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 all the way to positive infinity. But what did I say about mathematicians? We are lazy. If we can create a symbol to communicate what we want, we will. And so we say x belongs to I for integers. But even the word belongs to is too long. And me writing in English belongs to is different from someone writing in Latin. Belongs to someone in Greek, belongs to someone in French, belongs to. And so we developed a symbol. It's an epsilon. It's like a little E, but curved. X is an element of X belongs to integers. So now I'm trying to introduce symbols to you. Don't worry, I give you the symbols here on the right side of the page. Okay. So introducing the first letter. Yes, ma'am. Absolutely, go for it. So if you take a look at the right side of the page, you will see a list of new symbols I'm gonna probably introduce to you. And the little epsilon, that's a curved E, is either belongs to or an element of. An element of. I, integers. Right? So I do it as an example. If I say x epsilon I, that means x is an element of integers. Doesn't that save so much space? And this is why mathematicians, as annoying as it is, developed a system, a symbol. Maria? Yes, the little bar thing. Yeah, that's sort of it's sort of like a way to bold the letter. Yeah, you will see even in textbooks that they either bold it or they italicize it. They do a funky thing. Okay. Yes, Cameron.
So for the domain, for what we were going over before, could we just do infinity and then the folded I? Wouldn't that also work?
Like x belongs to infinity.
No, I mean like for we were doing the domain for the previous graph, and you were saying how it would just be infinite integers, not just do infinity and then the folded I next to it.
I'm not sure if that would communicate the same symbol. So you're saying instead of what we did here, we can write, say that one more time,
Like, the infinity symbol, like I next to it.
like this.
Yeah. the whole nine.
I see what you're saying. Again, I'm sure they could have designed that as a system. But I think that might be a very exclusive for something like this. As we move on further, I think you'll see the efficiency in writing it this way, because there are some other things we could do to it after. You'll see. Okay. How about range? Range is a little bit more simplistic. What are the possible y values for this curve or for this line? How high or how low does this go? Jessica, what do you think? Yeah. Are there any other y values you see? No. The range is literally 1. I don't have to say it belongs to real numbers, it belongs to integers or anything like that. It's just 1. This is as simple as we can get. And so mathematicians are like, okay, I like that. How about the last one? Woo. Again, what's the domain? Well, it looks like it's going to positive infinity and negative infinity, right? But unlike what Janae was saying before, does this one have breaks in between? So it's any decimal. What family of numbers, what group of numbers include the decimals? Not integers, obviously. But I'll grade 9 teacher to this, so I think I did. I'm not sure. Remember? Any number. There is a family of numbers out there that fall under this any number category. You don't say any numbers, these are the something numbers. That's no? Yeah. Yes. Here was a clue. It was right there. R. Real numbers. Real numbers means anything, any numbers. Anything goes. Except the imaginaries, but we're not going to get there. So domain, I could go what? This is the inefficient way, right? So don't write this. I could go negative infinity, dot, 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 -1, negative 9999999, negative 0.99, negative 0.9, and then move on to 0.8 something. You get what I'm saying? That's annoying. I'm not going to include every single decimal in there. That's messed up. And so we say X belongs to real numbers. Done. And of course, we close it up with the squiggly brackets. XER. That communicates to the math world that that's it. Like it includes all decimals. Yes. The squiggly brackets represents that you're talking about a set of numbers, like a group of numbers or a family of numbers. Same with range, same as above. There's no up or down. This is just going to be a 1. And so that brings us to the end of our lesson. But as I said, it seems simple enough, but it can get tricky. I'm going to show you the domain of one of the easy ones in the front page, and then we'll do a domain of one of the harder ones on the front page. And the rest I'm going to ask you to do for homework. Let's see if we can complete that in the next 3 minutes, so you have a bit of a break before you leave. Go back to the front page. Let us do the domain and range of this line. Yes, it's slanted, I know, but how far left and how far right do you think this curve goes? Let's look at the positive direction. How far right? Someone. Correct. It will go to positive infinity. Yeah. How about left? How far left do you think this will go? The same. So we'll say negative infinity. And then Janae, are there breaks in between? No. So looking at that, how do we communicate to the world that this could be any X or Y, or any X value in the positive, any X in the negative? It's very similar to what we just did. Scratch that. I need everyone's hands up. Pay attention. Carter, come on. Put your foot down. What? How do we say we can have any numbers, period? X belongs to any number. Alex? Yeah. So domain for the first one, squiggly bracket. Let's get into the habit of writing a squiggly bracket. X belongs to real numbers. And you will notice that for both integers and real numbers, I draw a double line to show that it's like a special letter. It's just a thing. Right? And if you've gotten that, just move ahead. Think about the range. Look at that straight line for letter A. How high and how low does it go? Paige, could I ask you? Yeah, it goes up to infinity. It's going to go up and up and up and up and up. So it's going to be up to infinity. And how about down, down, down? Does it leave out any numbers? No. It includes every number possible. So this one's going to be squiggly line, squiggly bracket. Y belongs to infinity. So already, it's not about memorization. I'm asking you to look at a graph and talk to me about it. You already have to make your own decision on it. So it's going to require a little bit of courage, right? To look at something and state your opinion, saying this goes from here to here, right? But let's get some practice in. Zach, could I bother you today? Yeah, all right. This time I want to go straight into, I'll give you a choice. You want to do C because it's familiar, or do you want to do D because it'll give you an idea of using the same brain for things you've never seen before? Well, okay. Choose even or odd. Even, then let's go for D. Keep things simple. Here's a question you've never seen. Here's a graph you've never really seen before. But I'm going to go through the same process in my head to figure out what the domain is. Let's take a look at the domain. So the x's, left and right. How far right am I going, Zach? It's going to go to infinity. But what about the left side? Where am I stopping? Where's the wall? -4. And you could use your best judgment. In your opinion, do you think it's touching -4?
Sure.
Yeah. Okay. No, it's your opinion. Okay. So it's going to touch -4. How do we tell the world that it can be any X number, but it can't go past a -4? We're going to use some of these, some of the symbols that we talked about here. See it? We're going to be using this stuff right here. Here we go. Oops. Oh, stop share. Okay. So how do we state that it can be any X number, but it can't go under -4? So this is part D. I will say X could be any number. Now I have to state a condition such that, vertical line. You might want to write this down. Such that X must be bigger than or equal to -4. X has to be the big side of the mouth, or equal to -4. Yes. Yeah, so it's basically a regular R, but make the pillar double. Yeah, think about it that way. Okay, so you can put a little star next to that. You have to make that judgment call on your own. You have to decide how to communicate the domain. It's literally a language. Let's do this really quickly. I'm almost out of time. What about the height, the range? How high is this going? Well, it's really slow, but it's going to go up forever. How about this one? It's going to go down forever. And so the range is easy. It's still, y could technically be anything, because it'll go up and down forever. We'll just do this and get bigger. All right. Oh, sorry, I didn't think that it would take this long. I'm going to pause right here and just talk about homework.